Dear students, welcome back to a new mathematics session. In today's session, we shall discuss question number 10 to 15 from exercise 2.2 from the chapter Inverse Trigonometric Functions. Let's move on to the topic. Before starting the session, let's recall the domain and the range or the principal value branches of inverse trigonometric functions. First of all, sin inverse x, domain is closed interval minus 1, 1. Range is closed interval minus pi by 2, pi by 2. For cos inverse x, domain is closed interval minus 1, 1. Range is closed interval 0, pi. For cosec inverse x, domain is r minus open interval minus 1, 1. Range is closed interval minus pi by 2, pi by 2, excluding 0. For sec inverse x, domain is r minus open interval minus 1, 1. Range is closed interval 0, pi, excluding pi by 2. For tan inverse x, domain is r and range is open interval minus pi by 2, pi by 2. For cot inverse x, domain is r, range is open interval 0, pi. In the previous class, we have discussed a trick for recalling this range. For that, there is x-axis and y-axis we have to draw, and we have to mark 0, pi by 2, pi and minus pi by 2. And these are divided into 4 quadrants, first, second, third and fourth. And there are some inverse trigonometry functions whose range is coming between minus pi by 2 and pi by 2. So that is sin inverse, cosec inverse, tan inverse. But not exclusively minus pi by 2 plus pi by 2, but minus pi by 2, by using minus pi by 2 and plus pi by 2, these three inverse trigonometry functions we can write. For example, for sin inverse x, it is closed interval minus pi by 2 to pi by 2, and for cosec inverse x, excluding 0 we have to write, and for tan inverse x, open interval minus pi by 2 to pi by 2. Other three inverse trigonometry functions, the range is between 0 and pi. They are cos inverse x, sec inverse x, cot inverse x. But remember, for cos inverse x, closed interval 0, pi. For sec inverse x, we have to exclude pi by 2 from that. And for cot inverse x, open interval 0, pi. There are some other formulas also we have discussed in the last class. That is, sin inverse of minus x is minus sin inverse x. Cosec inverse of minus x is minus cosec inverse x. Tan inverse of minus x is minus tan inverse x. The other three trigonometric ratios like cos inverse, sec inverse and cot inverse x, if minus comes means cos inverse x means pi minus cos inverse x. We have to subtract from pi. And next is sec inverse of minus x is pi minus sec inverse x, and cot inverse of minus x is pi minus cot inverse x. So these are the formulas we have used in the last class, and please recall or memorize these formulas before going for the next slide. Next, let's recall the properties of inverse trigonometry functions. Sin of sin inverse x is equal to x, cos of cos inverse x is equal to x, tan of tan inverse x is equal to x, cosec of cosec inverse is equal to x, sec of sec inverse x is equal to x. Finally, cot of cot inverse x is equal to x. Another set, sin inverse of sin x is equal to x, cos inverse of cos x is equal to x, tan inverse of tan x is equal to x, cosec inverse of cosec x is equal to x, sec inverse of sec x is equal to x, and cot inverse of cot x is equal to x. Then in the previous class, we have discussed about the table of values of angles 0 to 90 degree, 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. We have to use this table for writing the values. And please make sure that the angles are converted into radians. Next, we have learned tan inverse x plus tan inverse y is equal to tan inverse x plus y by 1 minus xy if xy is less than 1. Tan inverse x plus tan inverse y, one more formula is there. If xy is greater than 1 means we will use pi plus the previous formula, that is tan inverse of x plus y by 1 minus xy. Tan inverse x minus tan inverse of y, we have learned the formula tan inverse x minus y by 1 plus xy. And to tan inverse x we have formulas sin inverse 2x by 1 plus x square, Next, cos inverse 1 minus x square by 1 plus x square, then tan inverse 2x by 1 minus x square. Next, let's recall some formulas which we have learned in class 11. That is double of x and triple of x formulas. Cos 2x, there are 4 formulas: cos square x minus sin square x, 2 cos square x minus 1, 1 minus 2 sin square x, 1 minus tan square x by 1 plus tan square x. Then sin 2x is 2 cos x sin x and 2 tan x by 1 plus tan square x. Tan 2x, 2 tan x by 1 minus tan square x. And 3x formulas, triple of x formulas, there is sin 3x is 3 sin x minus 4 sin cube x. Cos 3x is 4 cos cube x minus 3 cos x. Tan 3x is 3 tan x minus tan cube x divided by 1 minus 3 tan square x. So these, especially these 3x formulas, that is very useful for calculating inverse trigonometric questions. So please make sure that these formulas are by-hearted properly. Next, let's discuss how to derive some useful formulas which we will be using for solving inverse trigonometric functions. So we have learned sin 2 theta formula as 2 sin theta cos theta. Sin 2 theta is equal to 2 sin theta cos theta. From here, sin theta formula we are going to derive, that is, instead of theta we are substituting as theta by 2, because we want sin theta formula. So 2 we don't want. For cancelling 2, what we have to do is theta will be replaced by theta by 2, half of angle theta. So replacing theta with theta by 2. Then sin this 2 theta will be coming as 2 into theta by 2. That is here equal to 2 sin theta. Theta will be replaced as theta by 2. Cos theta, again here also theta can be replaced as theta by 2. Here 2 and 2 cancelling time, we will get sin theta is equal to 2 sin theta by 2 cos theta by 2. So from sin 2 theta, how we are deriving sin theta? That is what we have learned. Likewise, so many different formulas we can derive from double of angle formulas. So all I am not going to discuss here, only 2 we will be discussing, and the remaining we will be by-hearting. And you can try this one by replacing theta with theta by 2. So next formula we have learned as cos 2 theta. That is 1 minus 2 sin square theta. That is a formula we have learned. Here also cos theta we want. Means theta we have to replace with theta by 2 as before. So cos into 2 theta by 2 equal to 1 minus 2 sin square. This theta can be replaced as theta by 2. Here also 2 and 2 if we cancel, we will be getting as cos theta equal to 1 minus 2 sin square theta by 2. So little more adjustment if we make, this minus 2 sin square theta by 2 we can bring to the left side, this cos theta we can bring to the right side. That means we will be getting 1 minus cos theta. This cos theta going to the right side means 1 minus cos theta is equal to this minus 2 sin square theta by 2 comes to the left side, it comes as 2 sin square theta by 2. Means the formula what we have learned is 1 minus cos theta is equal to 2 sin square theta by 2. So these are the some formulas which we are deriving from double of the angle formulas. So there are some other formulas which we are using today's calculation. They are 1 minus cos x is equal to 2 sin square x by 2. That means from here, this is the formula. 1 minus cos theta is equal to 2 sin square theta by 2. Here angle instead of theta, just x we are using. 1 minus cos x is equal to 2 sin square x by 2. Next is same way 1 plus cos x is equal to 2 cos square x by 2. Next formula, tan of x minus y is equal to tan x minus tan y divided by 1 plus tan x tan y. Next formula, tan 3x is equal to 3 tan x minus tan cube x divided by 1 minus 3 tan square x. So these are the formulas we are going to use today's calculation. And this formula also you have to keep in mind, that is sin theta is equal to 2 sin theta by 2 cos theta by 2. So you have to memorize all these formulas. Next we shall discuss some more properties of inverse trigonometric functions. Here we will discuss 3 more inverse trigonometric formulas, that is sin inverse x plus cos inverse x is equal to pi by 2. The second one is tan inverse x plus cot inverse x is equal to pi by 2. Finally, cosec inverse x plus sec inverse x is equal to pi by 2. Here we have to group 6 inverse trigonometric functions from sin to cot as sin cos one group, tan and cot another group, cosec and sec the last group. Sin inverse x plus cos inverse x is pi by 2. Sum of tan inverse x and cot inverse x is also pi by 2. Finally, cosec inverse x and sec inverse x sum also pi by 2. So we have to recall all these formulas for solving the next few problems which we will be discussing from the next slide. Next, we shall discuss question number 11 from exercise 2.2. Find the value of tan inverse of 2 cos of 2 sin inverse 1 by 2. So we are asked to find out the value of these inverse trigonometric functions. Here, first of all, we will start from inside the bracket. That means sin inverse 1 by 2. Let's find out this value first. So here, sin inverse of 1 by 2, we can write it as, from here inside the bracket there is 1 by 2. From the table we have to find out for which value of sine it is 1 by 2, for which particular angle the sine is having the value as 1 by 2. So here it is 1 by 2, that is 30 degree angle. 30 degree angle means when we convert this degree into radians, it comes as pi by 6. So this entire term we can write it as sine inverse of sine of something. So when we write it as sine inverse of sine of pi by 6, this 30 degree when we convert into radians, it comes as pi by 6. 180 by 6 is 30 degree. So this 1 by 2 we have changed as sine pi by 6. And outside there is a sine inverse. So sine inverse of sine x, we have learned the formula. Sine inverse of sine x is x itself. So sine inverse of sine pi by 6 is pi by 6 itself. So first value we have calculated. So let's begin solving this question. Just write, we know that sine inverse of 1 by 2 is pi by 6. So we have directly written the value sine inverse 1 by 2. Of course we have a calculator, rough calculation we have done, but we can write here direct value. Sine inverse of 1 by 2 is pi by 6. Then when we substitute into the given statement, tan inverse of 2 cos of 2 sine inverse 1 by 2 will come as tan inverse of 2 cos of, here 2 sine inverse 1 by 2. Sine inverse 1 by 2 we have calculated as pi by 6. So 2 into pi by 6 will be coming here. 2 into pi by 6. Here this 2 and 6 we can cancel and write 3. So it will be coming as tan inverse 2 cos pi by 3. So here it will come as pi by 3. Pi by 3, here this value we have to write it from the table. Of course table we should not draw. We should recall the value and write. That is the way we have to solve in the examination. That is tan inverse of 2 cos pi by 3. Cos pi by 3 means 180. 180 by 3 when we convert this into degrees. 180 by 3 is 60 degree. Cos 60. Cos 60 value is 1 by 2. Here it is. So that is what it is written. Cos pi by 3 we have to change as 1 by 2. Then the 2 and 2 we can cancel and we will be getting the final statement as tan inverse of 1. Tan inverse of 1 means we know that from the table, tan for 45 degree tan angle is 1. So tan 45 is 1. 45 means we will be converting this one into radians as tan pi by 4. This 1 we will be writing as tan pi by 4. This is in the format tan inverse of tan of something. So tan inverse of tan of x is x. So tan inverse of tan pi by 4 is pi by 4. So the answer is pi by 4. The value of the given statement is pi by 4. Move on to question number 12. The question is find the value of cot of tan inverse alpha plus cot inverse alpha. So inside the bracket when we observe here, this is in the format tan inverse x plus cot inverse x. We have learned the formula tan inverse x plus cot inverse x is pi by 2. So directly we can remove this and we can write as pi by 2. That is cot of tan inverse alpha plus cot inverse alpha is equal to cot of pi by 2, because we know that tan inverse x plus tan cot inverse x is pi by 2. By using that formula we have written here the statement. Then cot of pi by 2. Cot pi by 2 means pi is 180. 180 by 2 is 90. So cot 90 value is 0. Directly we can write cot 90, the value is 0. So the answer is 0. Next we shall discuss question number 13. Tan of 1 by 2 of sine inverse 2x by 1 plus x square plus cos inverse of 1 minus y square by 1 plus y square. We are asked to find out the value of this one. So here, when we look at inside the bracket, when we observe inside the bracket, and we have to check whether this can be connected with any formula which is related to sine, because outside there is sine inverse, and we need to check here this term whether we can connect it with any formula which is related to cos. So here 2, if x comes as tan theta, 2 tan theta by 1 plus tan square theta, if it comes, we can write it as sine 2 theta, because there is a formula sine 2 theta is 2 tan theta by 1 plus tan square theta. So when we replace x as tan theta, we can bring this one to sine format. And here 1 minus y square by 1 plus y square, there is a formula in terms of cos, because outside cos is there, inside also we want cos. So this 1 minus y square, instead of y, if you put tan of a particular angle like tan alpha or tan beta or something like that, when we write this one as 1 minus tan square alpha by 1 plus tan square alpha, this one will be in the format cos 2 theta. There is a formula cos 2 theta is equal to 1 minus tan square theta by 1 plus tan square theta. So if you replace x as tan theta and y as tan alpha, then we can change this first term as sin 2 theta and the second term as cos 2 theta. So we have a rough plan of how this one can be solved. By using that plan, we will move. Let's take these two terms separately. First, we will take the first term sin inverse 2x by 1 plus x square. As we discussed before, x we can substitute as tan theta. Then sin inverse 2x by 1 plus x square will be coming as sin inverse of 2x can be replaced as tan theta, that is 2 tan theta by 1 plus tan square theta. We have discussed sin 2x formula, 2 tan x by 1 plus tan square x. Here instead of x, theta is there. So it will be coming as sin inverse of sin 2 theta. So sin inverse of sine of a particular angle. Sin inverse of sine of x is x. Sin inverse of sine of 2 theta is 2 theta itself. So first statement, the calculation is done. We will go with the second one, cos inverse of 1 minus y square by 1 plus y square. As we discussed before, let's substitute y as tan alpha. Here theta we have taken and here alpha we have taken because two variables x and y. So angles also must be changed. Then when we substitute the value of y, it comes as cos inverse of 1 minus tan square alpha by 1 plus tan square alpha. And we know that cos 2x formula 1 minus tan square x by 1 plus tan square x. So when we use that formula, this term will come as cos inverse of cos 2 alpha. Cos inverse of cos 2 alpha is 2 alpha. Now two terms values we have calculated separately. Now let's put this one into the original statement. That is tan of 1 by 2 into sin inverse 2x by 1 plus x square plus cos inverse 1 minus y square by 1 plus y square is equal to tan 1 by 2, that is outside. Inside the first term we got as 2 theta, second term we have got as 2 alpha. And in these two terms there is 2 common. Let's take out, that is tan 1 by 2 into theta plus alpha. First time 2 going out means theta balance, second time 2 going out means alpha balance, and 2 can be cancelled. Finally we will be getting as tan of theta plus alpha. Again this is in the format tan of x plus y. So there is a formula tan x plus y is equal to tan x plus tan y by 1 minus tan x tan y. By using this formula, let's expand this one. That is tan x plus tan y. Here instead of x theta is there, instead of y alpha is there. So tan theta plus tan alpha by 1 minus tan theta into tan alpha. Then tan theta we have substituted before, tan theta as x plus y. Tan alpha is y. Here we have substituted 1 minus tan theta again x, tan alpha y. So 1 minus xy will be coming. So final answer will be x plus y by 1 minus xy. Next, let's discuss question number 14. If sine of sine inverse 1 by 5 plus cos inverse x is equal to 1, then find the value of x. Here there is a statement like an equation. Here we are asked to find out the value of x. So let's write the statement. Sine of sine inverse 1 by 5 plus cos inverse x is equal to 1. So here left side there is a sine That means right side also we should bring the sine format. So this one we have to change the sine of a particular angle. So that can be written as sine of sine inverse 1 by 5 plus cos inverse x, that is left side as it is same we have written, is equal to, we know that sine 90 is 1. So this 1 we can write as sine 90. Sine 90 degree means 90 is in degrees. So we have to convert that 90 into radians, means pi by 2. So sine 90 is 1. We can change sine 90 as sine pi by 2. So sine pi by 2 is 1. Now left side also sine is there, right side also sine is there. That means these two terms will be equal inside the bracket. Sine inverse 1 by 5 plus cos inverse x is equal to pi by 2 we can take. Let's write that one. Now this is in the format sine inverse x plus cos inverse x is equal to pi by 2. From here directly also we can write, because sine inverse x plus cos inverse a particular value here, then this sum will be equal to pi by 2. Here this value and this value should be same, then only we will get the angle as pi by 2, because we know the formula sine inverse x plus cos inverse x is equal to pi by 2. Here instead of x it should be 1 by 5. Directly also we can write, but we will go with the proper calculation. We'll take sine inverse x plus cos inverse x is equal to pi by 2. From here sine inverse x we will calculate, means cos inverse x we can take to the right side, that is pi by 2 minus cos inverse x. Then here we can write as sine inverse 1 by 5 is equal to, this term we can bring to the right side, that is pi by 2 minus cos inverse x. So pi by 2 minus cos inverse x is sine inverse x. We have already derived here. So sine inverse of 1 by 5 is equal to sine inverse of x. So both the side there is sine inverse, means this 1 by 5 and x will be equal. So from this statement we can say that x is equal to 1 by 5. This is the proper calculation, or else from here itself directly we can write, because by using this formula sine inverse x plus cos inverse x equal to pi by 2 means here also x, here also x. That means here 1 by 5 means here also should be 1 by 5. X is equal to 1 by 5 directly also we can write. Move on to question number 15. If tan inverse x minus 1 by x minus 2 plus tan inverse x plus 1 by x plus 2 is equal to pi by 4, then find the value of x. Here also we are asked to find out the value of x. So left side when you check, it is in the format tan inverse x plus tan inverse y. We have learned the formula of tan inverse x plus tan inverse y. So let's take the left side alone and we will do a little bit of calculation. By using the formula tan inverse x plus tan inverse y is equal to tan inverse x plus y by 1 minus xy. Here x is this term and y is this term. So the calculation will be a little difficult here. You need to take utmost care. That is tan inverse x plus y, that is x minus 1 by x minus 2 plus x plus 1 by x plus 2, that is written sum, divided by 1 minus the product, that is 1 minus x minus 1 by x minus 2 into x plus 1 by x plus 2 we have substituted here. Now normal calculation inside the bracket, let's take the LCM. When we take numerator LCM, it comes as x minus 2 into x plus 2, it's written. Then this x plus 2 will be multiplying here, x minus 1 into x plus 2, and this x minus 2 will be multiplying here, this one, so x plus 1 into x minus 2. Denominator, when you take the LCM, x minus 2 into x plus 2 common LCM we have taken, and here there is no denominator, so let's multiply this entire term with 1. So 1 into x minus 2 into x plus 2, that is x minus 2 into x plus 2, minus the same term, because there is a denominator, so the same term will be coming x minus 1 into x plus 1, divided by x minus 2 into x plus 2. When you check, numerator is having a denominator as x minus 2 into x plus 2, the denominator also having a term which is having the denominator x minus 2 into x plus 2 common, so we can cancel both. Then we will be getting tan inverse x minus 1 into x plus 2 plus x plus 1 into x minus 2 divided by x minus 2 into x plus 2 minus x minus 1 into x plus 1. So the remaining terms we have written here. Now we will go for removing the bracket. While removing the brackets, you need to take utmost care, because when you miss out a term, the answer will be wrong. That is tan inverse x into x, that is x square, then x into 2, that is 2x, minus 1 into x, that is minus x, then minus 1 into plus 2, that is minus 2. first brackets removed. We'll go here plus x into x, that is x square, x into minus 2, that is minus 2x, 1 into x, that is 1x, that is x itself, plus 1 into minus 2, that is minus 2. When denominator comes, x plus 2 into x minus 2, a plus b into a minus b, that is a square minus b square, that is x square minus 4. Then x minus 1 into x plus 1, this is also a minus b, a plus b form, that is a square minus b square, that is x square minus 1 square is 1. So x square minus 1 is there, that minus will be taking with this minus and comes as plus, so plus 1. And the denominator, just we have done some mental calculation. So if you feel it difficult, write one more step. Once again I will explain. Here I have done grouping also. So x plus 2 into x minus 2, that is a plus b into a minus b format, will come as a square minus b square, that is x square minus 4 will be coming. So I have taken x square and minus 4 is here. Then here there is a minus, don't forget, and here will come as x minus 1 into x plus 1 will be x square minus 1. So x square minus 1, when you take with this minus, minus x square will be coming. Then minus of minus, there is a plus, plus 1 will be coming. And there is common terms we can cancel, sorry, opposite signs, like terms with opposite signs we can cancel. That is here plus 2x minus 2x we can cancel. And minus x plus x we have cancelled, and the denominator also there is x square minus x square we have cancelled. So there is remaining terms we can collect tan inverse. Here there is an x square, here there is one more x square, so x square plus x square is 2x square, and here there is minus 2, and here there is one more minus 2. Minus 2 minus 2 is minus 4, and denominator is having minus 4 plus 1. Minus 4 plus 1 is minus 3 we have written. So we have calculated the left side. Then we can take the entire statement, tan inverse x minus 1 by x minus 2 plus tan inverse x plus 1 by x plus 2 is equal to pi by 4. And let's substitute a left side value, that is tan inverse 2x square minus 1 by minus 3. This left side term will be coming as this one that we have written is equal to right side is pi by 4. And here just to take this tan inverse to the right side, that is 2x square minus 4 by minus 3 is tan pi by 4. Tan inverse when moves to the right side, it comes as tan pi by 4. And we know the tan pi by 4 value, that is 1. So 2x square minus 4 by minus 3 is equal to 1. Next, when we cross multiply, 2x square minus 4 is equal to minus 3 into 1. Minus 3 into 1 is minus 3. Then rearrange it, 2x square, this minus 4 when it comes to the right side, it comes as plus 4, minus 3 plus 4. So 2x square is equal to 1, 4 minus 3 is 1, and x square is equal to 1 by 2, and we are asked to find out x. X is equal to root of 1 by 2, that is plus or minus 1 by root 2. X is equal to plus or minus 1 by root 2 is the required answer. Dear students, today we have discussed question number 11 to 15 from exercise 2.2. Before start solving these questions, I request all the students to write all the inverse trigonometric formulas in a sheet of paper and try to solve these questions independently. And while solving, if you have any doubt, please note it and keep. We will discuss it during the discussion session. Thank you for watching.